behind Skype. Again, a lot of Skype operational details are not known outside of the company. And then briefly talk about BitTorrent before we move on to further details that is publicly available about BitTorrent in the next module of the lecture video. So for Skype, we need to first think about making phone calls. Okay? The phone call could be from an IP device to an IP device, or from IP device to a normal phone on the phone network. And Skype is best known for making IP to IP phone calls, which are free. Now, making phone calls is intrinsically P2P. Okay? A pair calls up another pair. Okay? You do not call up a server, for example. So it's intrinsically P2P for voice call themselves. But also the control signaling, that's what really makes Skype tick. It's to say that in order to discover the other IP phones, what you need to do is to use the peers as an infrastructure for discovering the connectivity. So the peers collectively act like a bridge, okay, and they can bridge two IP phones. Let's say you are one of these nodes on Skype network. Now you see some of these nodes are bigger because we'll later call these super nodes, SN, okay, as opposed to just a node. Now when you want to make a Skype call, first of all, you have to log in at a server. Okay, so the server will authenticate you, make sure you are indeed a Skype user, and then you tell the server that, hey, I would like to call up the following Skype user. Okay. And then the server will direct you to a particular supernode. And then your communication will be carried out by a supernode. Now, these supernodes are basically just like a normal node. And some of your desktop machines might be used as a supernode, and you may not even know that. Okay. So basically, any nodes that has a public IP address. You may recall from 2 lectures ago that IP address could be public or it could be hidden behind firewall or network address translators. Okay, this one is public and it should have abundant resources, including upload bandwidth, CPU power, memory, and so on. So an ordinary node will connect to a supernode because it knows the public IP address. So let's say if you want to make a phone call to your friend who is a Skype node over here, and let's say this one sits behind some kind of firewall, okay, or network address translation. So you cannot actually directly locate this IP node. Now in a telephone network, the old telephone network's been there for 100+ years, you would need maybe a switchboard with human being there or not, mechanical or electrical, in order to connect you to that phone. But in the IP world, what can you do if this is sitting behind some kind of firewall or net? Well, the good news is that it talks to its own supernode, and these supernodes have public IP addresses. So this supernode will form a communication path with this supernode, okay, and then this supernode would then further connect to this node, and therefore these 2 supernodes collectively act as a bridge to enable the discovery of end-to-end connectivity between 2 Skype nodes. Once that connection is established, they could agree to bypass one of the supernodes if they want. Okay, but at least now caller and callee are directly connected. Okay. So the main idea behind the Skype is that we can discover end-to-end connectivity via the help of peers, especially these powerful peers with public IP address called supernodes. Now BitTorrent, in contrast, uses P2P not just for connectivity discovery, but for actual content sharing. So a typical BitTorrent graph may look like this. This black dot is a BitTorrent machine, and say your machine, okay? And it would like to engage in a torrent. And what it does is to first communicate again with a server managed by BitTorrent, authenticate yourself, and obtain the IP address and port number of another hardware called the tracker. Okay, this tracker got a database that it keeps track of, and then when you talk to the tracker and say, you know what, I would like to participate in the torrent of watching a particular movie. Okay, now the movie may or may not be properly digital copyright protected, but let's say we ignore that part. Okay, the tracker then will then say, all right, good, I can tell you that in your proximity, okay, you've got following whatever number 8 neighbors, okay, and you can form connection with them. Okay, and notice that they may be forming connection among themselves as well. Now, how do you decide what neighbors to pick as peers to actually do transmission of packets? That's something we'll talk about very soon. But as you can see, the main idea behind BitTorrent is that often you need to do multicast. So far, our attention has been unicast, meaning that one source to one destination. Multicast is one source to n destinations. Now, you may have heard of doing multicast in the IP layer, in the network layer, but except for certain control channel, except for IPTV that we talk about in lecture 18, and except for local area networks, LANs, there are 3 main kinds of exceptions. You do not see IP multicast really widely adopted. Part of the reason is management overhead, and instead an architectural alternative to doing multicast one-to-end delivery of packets in the network layer is to do it in the application layer, also called application layer multicast, meaning that I do not have to figure out how can I actually establish multicast capability from one source to, say, 3 end hosts, 3 destinations. I'm going to build an overlay network, okay, among these nodes, and then build some kind of tree in the application layer. So the network layer does not need to be bothered. Now, some say the IP multicast would have been a more efficient solution, but it does carry the price of managing the overhead. So BitTorrent is an application layer multicast. And the key idea is to say, I'm going to divide the file we're going to share, whether it's a text or a movie, into many smaller granularity units called chunks. Okay? And then the tracker will see which peers possess the chunks that you need, and then give you a list of what we call neighbors. These are the potential pairs that can share content with you. Potential pairs. And then you have to pick a subset of these neighbors as the actual peers. Okay. And we're coming to describing very smart ideas behind BitTorrent in doing that. So each chunk in this multicast process follows some kind of tree. Okay, I got, let's say, 6 peers labeled from A to F. And this blue square or rectangle is a particular chunk, and if you look at the lifetime of this chunk, it basically follows some kind of tree pattern. Okay. It doesn't form a loop back because that would be very inefficient. However, one single session of multicast in BitTorrent consists of many chunks, and these different chunks can traverse different kinds of trees. For example, in this graph, you can see that these 6 nodes can form all kinds of connectivity patterns. In the advanced material part of the lecture, we'll look at optimizing their connectivity pattern. But right now, let's say the dot solid line are the actual peering relationship formed, and the dotted lines are those peering relationships that could have been formed but are not at this particular instant. And then next time instant, we may see a different kind of connectivity pattern. Okay, so if you're looking at a lifetime of a particular chunk, it traverses a tree, but if you look like the overall, it's more like a mesh rather than a tree. Now both BitTorrent and Skype, as we just saw in a very basic description, are overlay networks. Now we've been using this term a few times already. What exactly is an overlay network? Now think about the following topology. You got a graph, which is a set of nodes and a set of links. Okay, the white circles are the nodes in set V, and then the solid lines are the links in set of edges E. Okay, that's given to you. And the overlay says, you know what, I would like to establish a connection between this node and this node. So I'm going to draw this on top of it in dark, just to differentiate. These two dark nodes are logical entities, a source and destination. I want to find a path, let's say this dotted line, to connect them. And similarly, I can say I want to take this node and form a connectivity between them. So think of, it's hard to draw this on 2D, but think of 3D where these black dots, 4 of them, and the dotted lines sort of lies right above this plane. Okay. Now you may say, what about this node? Well, this node is not part of the overlay network. It is used basically as a bridge or relay in the underlying underlay network. So we can define the overlay network represented by another graph, G2D. It also consists of a set of nodes and a set of links, V2D and E2D respectively. But the set of nodes here is a subset of the original one. In other words, V2D belongs to the original set V. For example, these 4 black nodes are subset of the original one. And there are some nodes that were in the underlay G but not in the overlay G2D. They are hidden from the viewpoint of the overlay network. And furthermore, each link, each element in this set E2D in the overlay network is really a path by concatenating different links in the underlay graphs. Okay, so overlays, a link in overlay is really a path in the underlay. Now what does the overlay graph look like in this case? It's a very strange looking graph, but nonetheless, we basically got these 4 nodes, and there are 2 links. One link is the path, this one in the underlay, the other is this path in the underlay. So you actually see just 2 parallel lines. That is our new graph G2D, which is disconnected graph. And just by looking at this G2D, you would have no idea that actually there is another node hidden there, and furthermore, actually both links actually use this underlying physical node. Okay, they have a shared fate. If this node goes down, both connections would go down. That information is also hidden from the graph representing G2D. So this is the idea of building overlay. And you can say, you know what, if I cannot change the routing protocol down there, I'm going to just establish a tree or mesh or some kind of graph among the source and destinations. Let's say these are the BitTorrent machines alive at a given time. And then build my own network G2D. That is the powerful idea of overlay.